Okay, given an open cone with a radius of 3.25 centimeters, a vertical height of 21 centimeters, and a slant height of 21.25 centimeters. We're going to make a piece of paper. We're going to actually look at the vertical depth, the volume, and the rainfall depth. Okay, and we're going to derive three functions that look at this. I'm going to do it in probably three pieces. We'll just kind of see how it goes. The slant height is going to be our main measurement of distance, and I'm actually going to reference these in varying variables. So right now I'm going to call my vertical height, I'm going to call it VH or capital H, and my slant height I'm going to call capital L. Now I might also reference slant height individually, a particular slant height or a mark on that would probably be denoted with lowercase s. This would be my mark on slant side, on slant, okay? And then we'll be looking at h, lowercase h, will be our vertical depth. So lowercase h will be our vertical depth. Depth of the water, and then I'll use capital V for volume. Volume of cone, volume of water, volume, water in cone. Now I'm doing this rough, so obviously you should be neater. And then D, and putting all this here. This would be in like your main page, so this probably wouldn't fit on the one that has the ruler, but I'm going to try to make everything fit, at least for the example I'm giving here. This is rainfall depth. And this is basically the rainfall falling on the mouth of the cone. We're using a cylinder, that shape, though it's still going into a cone, mouth of cone. Okay, so that's kind of what we're doing. We're going to derive some functions. So we'll have like S will be our function, maybe. S up here, we'll make this our function. So we're going to have a S of H, S of V, S of D sort of thing. So that's kind of the idea. That's what we're going to do throughout the process of this. So first let's start with the depth scale. And let's see, did I give myself enough room? Sure, I gave myself enough room for the way I'm thinking of this. And probably the way you should also. So let's see. This is okay. This is a just rough sketch here. Okay, ignore the numbers because I really don't care. Go to here, and then I want a slant height, and we'll go to keep that. We'll go to here, whatever that is. And then I have this up here. Oh, look, I made a nice triangle. And it's a right triangle, right? I know it's a right triangle. By design, right? This should be my radius. This is my vertical height, or capital H. And this is my L. Now, if I want to know the relation of this H, that's my water. It's fancy water. Okay, so I want to know this H. From here to here, I want to know this H. And I want to know where that mark is on here, right? Where is that mark on here? Well, this is lowercase a s, right? Whatever we want to call it. We could call it h. It doesn't really matter. And this is some value, okay? It's something. Here's what I know about triangles, and it's going to blow your mind because you all should know this. They're similar. If this triangle, this little triangle here, right, is also a right triangle at that height. It is a right triangle. Right triangle, right triangle. This side is proportional to this side. This whole side is proportional to this side. And this diameter, this radius, is proportional to this radius. I don't know the radius at this particular point. I don't need to, because I know that there's a ratio here and a ratio here. So let's kind of put that up here. Let's kind of write that down. What do we have? I know that S to H should equal L to H. So I should have S to H should equal L to H. Well, I want to know what H is. I'm going to multiply. So I'm going to create a function. You should show the steps. I'm not. Why? Because it's your benchmark, not mine. And this would be LH times H. Great. Here's the thing. I know what L equals. I know what H equals. And I know capital H. I know what L equals. I know what capital H equals. I can determine what one height is, because remember, you're doing every centimeter of height. Where is that on the vertical stretch? Where is that over here? So I would plug my numbers in. They're up here. They're written wherever you wrote them. And I would plug in 1 for H, and then plug in 2 for lowercase h, and then plug in 2 for lowercase h, and then plug in 3. And then I would plug in all the way until I got to 21. And they're going to be different marks on your sheet. Now, 1 is just going to be somewhere above 1, not very high. Maybe it's 1.1. Maybe it's actually not even 1.1. Can I do that? Something like that, right? It's all just above 1. And then it's going to be just above 2, some amount, and so on up the line. But at some point, because 21.25 up here, 21.25 is the whole slant height, right? My whole slant height is 10, 20, right about there. 10, 20, yeah, right about there. That is 21 inches vertically on this, 21 centimeters on this is 21.25 here. So I'm going to measure 21 of these by replacing this h with those values, and I'm going to put them up here. You want to round to at least 2-3 decimal places, just so you know where you're at. This one is 2 decimal places, so I would say you need to go probably 3 so you can see how it goes. And you're going to mark them on here. You're going to mark these S's, and they're going to have a relationship to the vertical height, this vertical height of our cone. And look at that. You're going to write about it. You're going to give me some words on here. But basically, this is like, let's look back at this. So this work here, and really I need the S and I need this. I don't need these two on this page. I could put them on the other page if I'm trying to write everything I need on this page. I do need the diagram to make the relationship, but this is it. this is everything that's on this piece, except for you would have your calculations, you would have your marks on your line going up. You would say mark here, I think it's 1.0119 approximately. Don't quote me, I'm doing that in my head. This would be S, right? This would maybe be S, 1S, well, S. And then you'd have a point wherever 2 is, and you would have 2S. And then you'd have a point wherever it is 3. And remember, it's not this 3. I'm asking for the height at 3 centimeters. So what does that relate to over here? Well, that's what it relates to. It relates to this S is 1 centimeter of height. This S equals 1 centimeter of height. And then wherever the next one is, 2S would equal 2 centimeters of height. And 3S would equal 3 centimeters of height. Not angle or not length on the side, but height of the water going up it. And there is, I mean, obviously there's a little bit of write-up where you're writing on the relationship here. That would have to be written in the document, but a lot of this you can do, a lot of the calculation stuff can be done by hand writing here. You know, you don't even need you'll need a calculator to do some of the rounding, just because I don't know that you guys have the same, you rely on it, so you kind of don't have a choice. But this is, 21.25 divided by 21, which is a little bit above 1. It's like I said, about 1.011-ish, 119 maybe, 1.012 maybe. Anyway, that's just me doing it in my head, but I have skills without a calculator. I don't need those. You probably need your calculators. You can do it by hand, though you'll probably need more room. If I was doing this by hand and doing that division, I'm sure I would need more room. Anyway, do them up, mark that page up. This then becomes, this whole piece becomes the picture you take and you put in your document for the relationship of the depth scale. All right. And I'll do another one for the volume scale. I may or may not do. I may start you on the actual depth, rainfall depth. We'll see how it goes.